So this is a double shear test on mild steel and aluminum rod, right? So that what is the objective of this experiment? To perform a double shear test on the given mild steel and aluminum rod, and to find the shear strength using the UTM machine. Shear strength, that is the objective. This is a specimen. This is a specimen. The size of the specimen diameter is 12 millimeters and length is equal to 55 millimeters. So prepare the specimen first. Now this is a shear box. So here there's a rectangular hole. Inside the rectangular hole, you fix this rectangular box. You fix this. Now this hole and this hole will coincide. So now we have the aluminum rod. You fix it inside the hole. So it will be looking like this. It will be looking like this. So from the top you have to apply the load in the downward direction. So this aluminum rod will be subjected to double shear. Will be subjected to double shear. So this is the way you have to apply the load. You have to apply the load. This gasket is moving in the downward direction, and it is subjected to shear load. Double shear failure will take place. So this is the dial where we can take the load. How much amount of load is applied. So here there are buttons to move the gasket manually as well as hydraulically. So now we can see how the load is increasing. These are all the observations. Name of the sample. Here it is aluminum rod. Diameter of the sample 12 millimeters. Load at shearing. What is the load? You take the load in the dial and you write it. Then calculation. Then you have to do calculation. Load by area. Double shear means 2 times that area, cross section area. So this is the equation. That is shear stress tau is equal to F by 2A. F is equal to the maximum load applied. 2A, 2 into area. Area is equal to pi by 4 d square. Here you are putting, you are using 2 because here it is double failure takes place. So we are taking 2, double shear. Then you do the calculations. Finally you write the results. Actually you have to do test for mild steel as well as aluminum. So the shear stress of the aluminum you write here. Shear stress of the steel you write here. Aluminum you write here. This is a diameter of the specimen. So this is a way you have to do this experiment. So this is universal testing experiment. The name itself universal. It is used for testing different specimens, different tests. That is, you can do tensile test, you can do compressive test, you can do shear test. So then that's what it is called, universal testing machine. So first we did tensile test using this universal testing machine. Now we are going to do shear test. Now we are going to shear test. So here we are going to apply a producing the shear test. Here the workpiece is fixed here. Workpiece is fixed here. From using this gasket, the load is applied. Load is applied. So it will become a shear stress because, see, this is known as shear box. This is known as shear box. Here, see, there is a hole. So now, we have to, so this is a specimen. This is an aluminum specimen of 12 mm diameter. Now, in the shear box, see, here there is a hole. Here there is a hole. Similarly, here also we have hole. Here also we have hole. So in between the hole, we have to fix this workpiece. You have to fix here. You have to fix here. Now you see, you keep like this. You keep like this. Now in the hole, you put the specimen. You put the specimen. Now the specimen is fixed. Now the specimen is fixed. See, when the load is applied here, when the load is applied here, here there will be a shear failure. Shear failure. See, when load is applied, there will be a shear failure. So from this, you can find the shear stress. Now sir is fixing the workpiece. Now he's fixing the shear box. Now he is applying the load. Now he is applying the load. He is moving the gasket down. See, he is moving the gasket down. So this will apply force on the shear box. When the force is applied here, this uh, uh, aluminum workpiece will be subjected to a shear failure, yeah, shear load. It will be subjected to shear load. So failure will take place. So the failure will be shear failure. The failure will be shear failure. So from the load and cross section area, we can find the shear stress. We can find the shear stress. When the load is applied, so load will slowly increase. At one point, it will fail. We know that the cross section area is 12 millimeters. 12 millimeters. Here the failure is double shear. So pi by 4 d square into 2. So that's the area and applied load. So using the area and load, you can find the shear stress. Now, slowly, now the cross head is just touching the shear box. It is just touching the shear box. Now he's going to apply the load using hydraulically. Now he is applying the load using hydraulically. Now he is switching on the yes. Now switched on. Now it is pressing. See, load is increasing. This gasket is moving downward direction. Moving downward direction. It is applying the shear load. It is applying the shear load slowly. Now he is opening the oil supply. Now he is opening the oil supply. You have to take the load from this dial. From the dial, you have to take the reading. So here, load is applied. Load is applied slowly. Load is applied. You have to apply the load till it fails. Till it fails. Yes, load is slowly applied. Now see, load is applied. Now it is head is moving in the downward direction. The gasket is moving in the downward direction and load is applied in the workpiece. The type of failure is shear, but it is double shear. Now, load is slowly increasing. It is going to reach 20 kilonewton. It is going to reach 20 kilonewton. It is now 20 till it not failed. Till it not failed. The load is crossing the 20 kilonewton. Slowly it is increasing. The readings are 10, 20, 20. It is increasing about 20. But now the load is not increasing too much. Slowly it is increasing. Yes. See, this is a maximum load. This is a maximum load. This is known as braking load. This is known as ultimate load. But till it not fail, but the load is decreasing. Load is decreasing. The maximum load is 20. Now it failed. Now it failed. The maximum load was 22 kilonewton. 24. 24 kilonewton. It is 24 kilonewton. The maximum load is 20 kilonewton. You have to take this load for calculation. This is a load you have to take for calculation purpose. That's the maximum load. Now, say this is a workpiece. This is a workpiece. It failed into 3 pieces. 3 pieces. So that here there are 2 failure. Initially it was like this. Initially it was like this. Here one failure, shear failure. See, initially the specimen was like this. Here one shear failure. Here also one shear failure. So it is called double shear. Double shear failure. So if you want to find the area, this is one area and this is another area. This is another area. So to find one area, what is the equation? It is pi by 4 d square. Pi by 4 d square. What is the diameter? It is 12 mm. So it is, since it is double shear, you find this area as well as this area. That is 2 times area. Load we know it is 24 kilonewton. 24 kilonewton. 24 by 2 into pi by 4 d square. This will give the shear stress. Okay, shear stress. So this is a way you have to calculate it.